Welcome to The Explainer, where we break down big ideas. So, today we're going to explore this really cool vision. What if the web wasn't just about linking documents for us, for people, but what if it could connect data for machines? Let's get into it. All right, so to build this smarter web, we've got to first get a handle on the problem it's even trying to solve. Okay, think about it this way. When you read a web page and you see the word Paris, your brain just instantly connects that to the capital of France, right? But to a computer, Paris is just a string of 5 letters. It has no idea what that word means or how it relates to anything else. So how do we even begin to build a web that machines can actually get? Well, we start with a whole new foundation, the Resource Description Framework, or RDF for short. The whole point of RDF is to basically create a universal language for data. It's all about making sure that when two different applications exchange information, the original meaning doesn't get lost in translation. This is the very first building block for what we call the semantic web, or the web of data. And you'll notice something really important about the structure here. Instead of a rigid top-down tree like you might find in XML, RDF uses a graph, and that was a very deliberate choice. It's meant to mirror the web itself, this huge, sprawling network of interconnected points. This flexibility is absolutely key, because it lets us easily pull together data from countless different sources. Okay, so at the very heart of RDF is this, well, it's a beautifully simple idea, really. It's called the triple. Every single piece of information gets broken down into a 3-part statement: a subject, a predicate, and an object. So for example, this book, that's the subject, is published by, that's the predicate, this publisher, that's the object. This simple structure is like the fundamental atom of the entire semantic web. All right, so having a foundation of just raw facts is a great start, but we need some rules to give them structure, right? We need a blueprint, and that's exactly where RDF schema, or RDFS, comes into the picture. You can think of RDFS as the tool that lets us create our categories and define the rules for all our data. It's how we can say things like, hey, a person is a class, or has author is a property. It's like we're adding this layer of shared understanding right on top of all those raw facts. Let's walk through a real quick example here. We tell our system a simple fact using RDF. This specific thing, we'll just call it my book, is a type of textbook. Super simple. Okay, but here's the question. You and I, we know that every single textbook is also a book. But how in the world do we get a machine to understand that same piece of common sense? Right now, all it sees are 2 different labels. And this is where our RDFS blueprint is so critical. We can add a rule that spells out the relationship. The class textbook is a subclass of the class book. We are literally teaching the machine how this stuff is organized. And boom, just like that, because we gave it that schema, the system can now infer that my book is also a book, and we never had to say it directly. That's the power of the blueprint. It lets the system do some automated reasoning. So, okay, we have our foundation, and we have a blueprint. But, RDFS is still a bit limited. It's great for simple hierarchies, but what if we need to express much more complex rules? For real intelligence, we need an upgrade. We need to go from a simple blueprint to the actual brains of the operation, the Web Ontology Language, or OWL. So for example, RDS can't really express something like a book can't be its own author, or that a bestseller is a book that's sold over 1 million copies. OWL takes it to a whole other level. It's a much, much richer language that lets us define these really complex concepts and relationships. And then it lets this special piece of software called a reasoner analyze our data, look for any contradictions, and even discover totally new facts that were only ever implied. Now, OWL isn't a one-size-fits-all kind of thing. It actually comes in 3 different species, and each one offers a different balance between how much you can say and how certain you can be that the computer can figure it all out. OWL DL, which is based on a formal system called description logics, that's often the sweet spot. It's powerful enough for most things you'd want to do, but it also guarantees that a computer can finish its reasoning and not get stuck in some kind of infinite loop. Now, this is a really fundamental shift in thinking that OWL introduces, the open world assumption. A normal database, right? It works on a closed world basis. If it can't find a piece of information, it just assumes it's false. But OWL, which was designed for the whole web, assumes that if it doesn't know something, it's simply, well, unknown. Think of it like this. If your company's employee database doesn't list a spouse for someone, it assumes they're single. But on the web, if someone's profile doesn't list a spouse, you can't assume that. The information could just be on another website somewhere. The open world assumption is built for exactly that kind of reality. Okay, so we've laid the foundation, we've got the blueprint, and we've even got the brains. So why does all this matter? What does this smarter web actually let us do? And you know what? This isn't just some academic theory. These principles are really in action today. You've got the gene ontology, for example, which uses this exact tech to let scientists query thousands of separate biology databases like they were all just one giant unified system. It's the kind of thing that can make a search engine understand what you mean, not just the keywords you typed in. It's the engine that powers systems that can discover new scientific insights completely on their own. At the end of the day, by building a web where data has clear, unambiguous meaning, a web that machines can genuinely understand, we're not just organizing information better, we're unlocking a whole new potential for discovery. So the real question is, what are we going to build with it? Thanks for joining me on The Explainer.